Review video 9, measuring potential. Refer to the figure to answer the questions. Determine the current flowing in the circuit. We have 3 batteries here and 1, 2, 3, 4 resistors. There's only one loop, so we don't really know necessarily because some of these batteries are pointing one way, some of them are pointing the other. We could probably figure out pretty easily which way the current is going to go, but I'm just going to assume that the current goes that way. And so if we write a loop equation, and I'll start right there, and we'll go clockwise. If we do that, we run into an 18-volt battery first, and then once again we're going to take a little bit of a shortcut here. We got the same current, I, all the way around. So when we go minus 1I, and then here we'll go minus 2I, minus 3I, minus 4I. I'm just going to combine those right now. Minus 10I. That takes care of all my resistors. Then we're dropping down in voltage, so we have to go minus 6 here, and then we're climbing up with that 18 plus 18, and then we're back at our starting point. How much does that give us? 30 minus 10I equals 0, so I equals 3 amps. And the fact that it came out positive means that we guessed the correct direction for the way this current goes. So which point has the higher potential, point X or point Y? We're going to say that it's going to be point X. And the reason it's going to be point X has the higher potential is because current is flowing in that direction. Point X should have the higher potential. We'll see if we can prove that to you here later, maybe. What's the name of the instrument that we would use if we wanted to measure the potential? Whenever you measure potential, you use a voltmeter. That's what that's called. Often found on a multimeter, which is a really handy device. And what kind of resistance do these voltmeters have? Really high resistance, because we don't want any current flowing through that. We just want to be able to measure the pressure difference. What numerical value would a voltmeter measure between point X and Y? Well, let's just pick a number here. Let's start right here, and I'm going to call that little portion right there, I'm going to say that that's 0 volts. That's 0 volts of electric pressure, which means that this portion here, we're jumping up by 18 volts. So this portion here got a voltage of 18 volts. Then what did we say? We said that the current was 3 amps. Remember that? So that means that the voltage is going to drop by I times R. It's going to drop by 3 going through here. So that means the pressure here is going to be 15 volts in that region right there. Then it drops by 6. So that means that this region is going to have a pressure of 9 volts. And again, all of these voltage values that I'm stating, those are all relative. Doesn't necessarily mean that that's exactly what it is, but the proportions are fine. So then the voltage is going to drop by I times R, and what was the current? It was 3, so it's going to drop by 6. So that means this region right here, which is where point Y is, will have a pressure of 3 volts. Let's see if this holds true all the way around. Let's see if we in fact do get back to 0 volts here. That will be interesting. So now we're going to bump up the voltage by 18 volts, so the pressure of that region is going to be 21 volts. Then we're going to drop by 9, which will give us 12 volts. That would be the color of that region right there. And then it's going to drop by another 12. Look at that. Again, all those numbers are completely consistent. So to answer our question, what numerical value would a voltmeter measure between point X and point Y? You can see it's going to be 15 volts, because a voltmeter measures pressure difference. And if this electric pressure were 18, that electric pressure is 3, then the difference is going to be 15.